Okay, so this video is just going to go through the while loop exercises in this page, practicing loops and conditions on the website. And there are, I just have, I think, 5 on here. And they're pretty simple, but it's good to go through these and do them on your own. Make sure you understand them. So let's start with this. The first thing I'm going to do actually is launch this binder. So I'll open up in a new tab and I'll see, hopefully that will launch. We'll go back here in the meantime, write a while loop such that you print out the first 10 natural numbers. And the 10 natural numbers begin with 1. 0 was not considered a natural number. I'm not sure why, but that's the way it was. So if I go over into my coding environment and let me comment that out. So we have to go 1 through 10, and that's pretty simple. Let me see if this is launched. There we go. And if I go over here, open up, I think it's number 2 here, close that off. So I have a coding environment here, and my kernel is running. And if I ran that, nothing would happen. But now I don't have tests in here, okay? I think you can test it pretty much yourself. But so I won't necessarily code it in here, but you can do that. But let's go back to here. So we want to print out 1 to 10, right? Easy enough. So let's start with a counter. We'll just say, you know, we could use any variable name we want, but we'll just say count equals, and we'll start it at 1. And then we'll say, while that count is less than or equal to 10, so it'll go up to 10, we'll just print out the count, and then we have to increment it, right? We have to go from 1 to 10, and that's easy enough. Plus equals 1. And just to review that, you could either do count equals count plus 1, and that'll increment it by 1, or put back plus equals 1, okay? And we covered that shortcut in class. So if I run this, let's see here, this is while loop, Python while loop, and it prints it out, 1 through 10, piece of cake, easy peasy. All right, so what's the next one? Write a loop that prints the following even numbers. Now, this is an interesting one. There's a simple way, not so simple way, but let's do both. So we'll copy that so we have it in here. And I'll replace all that. Write a while loop that prints the following even numbers, and those are 2 to 20 even. So let's try that. So let's start with count. And we're going to start at 2. And I said, while count is less than or equal to 20. So we wanted to go up to 20. Less than or equal to 20. And we can say print count. And the first count it'll print is 2. And then we increment it. Now, we don't do it by 1. We can do it by 2. So if I do that, and I clear that out and run it, we get, all right, the even numbers. But I want to show you something else, and this goes back to one of the operators, one of the mathematical operators, and that's the modulo. So let's say I started at, I will start at 1. And instead of incremented by 2, I'll just do 1. Well, if we run that, you get 2 to 20, right? Each one. But what if we did this? If we say if count modulo 2 is equal to 0, then you print the count, right? And what does that do? Well, so if I run this, let me clear it and run it, it does 2 to 20. Why is that? Because when the count is some a multiple of 2, count modulo 2 has a remainder of 0. And I don't know if I have this open. Yeah, I do. So in other words, if I said 1 modulo 2, that's 1. Well, that is not, if I said equal to 0, it'd say false. 2 modulo 2 is 0. So if I said that was equal to 0, boom. Said 3 modulo 2, that's 1. But if I said 4 modulo 2, we're back at 0. It's clock arithmetic. So you can use that as well. And actually that's really handy when you want to print just even numbers or multiples of 3. And we might see that in this video. If I have time, I'm going to go back and do a little extra work beyond what the problems are. But that's that one. So let's go to the next one. Clear that out. Write a while loop. Let's see. Write a while loop that processes all the lowercase letters and prints out a letter if it is a vowel. Now, this introduces another aspect or another feature. So there's a note here, preliminaries to writing a loop. Okay, a handy operator in Python is the in operator, which returns a Boolean answering whether some item is present, and it should be an iterable. I'll have to correct that, such as a string. For example, so let's take this, some character, and if I went over to clear this out, and I said some character is equal to that. If I said A is in some characters, it provides true. If I said, let's say, T is in some characters, it's false. So it returns a Boolean. This in operator looks through, iterates through, and it decides whether something is in it or not, is contained in it. So, and you'll see it runs some of this. If X, it checks for X, it's false, true here. So we're going to make use of that for this exercise. And if I copy this, let's copy all of that. So, so it's going to iterate through this, all these letters, lowercase letters. And then it's going to determine whether the letter is a vowel, and it'll use the in. So something like this. So by doing something, this count will take us through all of them, up to the length of the letters. So, so let's say if, well, I have to get the letter. So we're going to use the count, and we say the letter is equal to the letters, right? And then the count. And that will take us, it'll start at 0, so it'll be A, and then next iteration will be B. Say if letter in vowels print, and what do I want to print? Print out the letter. Print letter, okay? And then it increments it by 1. It starts at the top again. So if I clear that out, A, E, I, O, and U. So pretty simple, but once again, I will say, as I've said before, you're going to use a lot of conditionals inside loops. They go hand in hand. So there's that one. Let's see. Okay, so write a while loop that generates a random integer from 1 to 9 and only breaks out if the integer is equal to 5. So we import random, right? How do we get it? Well, from random, and I guess we could use this shortcut. And so we'll just say the integer I, we'll just say I equals rand int, and I said 1 to 9 inclusive. So that's 1. So so every time it starts the top of the loop, it generates a random integer 1 through 9 inclusive. Okay. Now, only if it only breaks out if the integer is equal to 5. So we just say if I double equals 5, and we break. Now let's print out I here just to see where we are. But if I clear that and run it, there we go. So 4, 4, 3, 7, blah, 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 no 5s in there, and then finally it hits 5 and it breaks out. And that's it. And then I think, okay. All right, this is kind of, let's see here. Then write a procedure. So this is a procedure, not just a while loop, that takes in an integer and prints backward from that integer down to 0 and then prints blast off. Houston, we have a problem. Let's see. So let's use the definition in here. And that's our, now it takes in, you can see it takes in a value here, an argument. That will be an integer. And while it's greater than or equal to 0, then it does something. So if we said print I, and then we have to increment I, I'm sorry, 1, and then we have to print blast off. Well, let's run this right now. Well, we have to call it first, right? So you have to say countdown, and we're going to say 10. So, whoa, what happened? I know what I did. So, let's see here. Oh. It should not increment. It should decrement. All right. As my father would say, stupid Irish. There we go. However, you'll notice something here. It doesn't have blast off. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then it should say blast off. Well, where do we put the blast off? Well, we can't put it in the while loop because that would print blast off at the end. If I said, for example, blast off, my little exclamation point. If I did that, you see it says blast off at the end of every number, and that would sort of throw the astronauts off. So we put it outside the while loop. I don't have to put that space in there, but I do it so you can see it's even now. So if I do this, run it, it's 10, 9, 8, counts down, and then blast off. So that's that. Just remember to decrement the integer. Let's see, and I think that's it. Now, there is one other that I would like to go through, and let me see if I have. I don't want to run the Python. So let me close that. So here, just to take a look at it, write a while loop to print the numbers from 1 to 100. Now, inside the while loop, use conditional statements so that, let me read that, so that if the number is a multiple of 3, print the number and 3's. If the number is a multiple of 5, print the number and 5's. If the number is a multiple of both, print the number and 3 5's. So, let's go over here. Let's get rid of that. So, well, let's just start. Count equals 0. And we're going to print while count is less than or equal to 100, right? We have to remember to increment count otherwise. So now this is where it gets a little hairy because we could do this a number of ways, but you have to be careful here. So let's go back into here. And remember we used, 2 modulo 2 is equal to 0, right? If something is a multiple of 2, whatever that number is for modulo 2 will be 0. So 6 modulo 2 is 0. In other words, there's no remainder. It's a whole number division. So that is to say, the quotient returns to you a whole number. Okay. So how do you determine if it is divisible by 3's or 5's? Well, it's the same thing. So if you say 3 modulo 3, it'll be 0. 6 modulo 3 is 0, right? And then for 5, same thing. 5 modulo 5, 10 modulo 5. So we use that like we did with 2, and we use it inside. This is going to be our condition. So we'd say if count modulo 3 is double equals 0, we print the count and we say 3's. So let's just test that out first, okay? And go over here, make this a little smaller. So you see anything that's that divides evenly, the quotient is a whole number divided by 3, right? So 12, easy to see some of these, 39, 42, 45. So there's a lot of those. Now we could do elif count modulo 5 double equals 0. Then we print that out. But there's a problem with that because it could be, if it's, it could be divisible by 5 and we miss out on that. So I think in a case like this, you just say, well, I mean, it could still be divisible by 5. Count modulo 5 equals 0. Print count 5s. So let's see what happens here. And you see that now. Interesting. If you look at 30, right, it does both of them, right? It says that 30 divides equally, or I mean into a whole number, whether it's 3 or 5. So both of those are factors. Well, then how do you do 3 and 5? Well, quite honestly, I mean, if you did else, that wouldn't work, right? Because there would be no condition, and you'd print all the other numbers, and they're not necessarily 5 and 3. So in the case of 30, how do you get that? Well, you could say if count modulo 3 double equals 0, and then use the logical operator and count modulo 5 double equals 0, print count, and then 3, 5. Is that what we wanted? So let's get rid of it. Let's get rid of this. Print 3 5s. Yeah, we'll leave it like that. Give us some real estate here. And okay, so let's go back to 30 here. So you see 30 does 3s, 5s, and 3 5, and 45 and 60. So every what is that? Every 15 it will do that. And that works. So anyway, it's a little extra credit right there. That's it for now, and we'll pick up on the flip side.